So Christmas came early and you got a new computer, a very expensive computer, $4,699. But sadly, like a lot of consumer electronics, it depreciates over time. So after 4.25 years, it actually lost so much of its value. Now it's down to $1,500. But you had a good time, played lots of games. It was worth it. So what we have here is a model for that depreciation, right? So the value y is equal to a times r, which is like the rate of depreciation, to the power of t being years. Our task is, all right, how much is this computer worth after 6 years? Right, we know how much it's worth after 4.25 years, and actually we know how much it's worth after 0 years, right, initially. So those are 2 points on a graph, and we're asked to find, all right, how much is it worth after 6 years? Cool. So just to summarize that, we know, let's do it graphically. So it's over time, so time is our x-axis, and y, the value, is our y-axis. We know initially, so at time equals 0, it's worth $4,699. We know in 4.25 years, it drops to a bit less than a third, so about here, of its value, so that's $1,500. And we're interested to know, or after 6 years, how much is it worth? But we can see as it depreciates, it'll depreciate more slowly, right? Once it's lost most of its worth, it doesn't lose as much over the same time period. And we want to work out that exact value. All right. Now going back to the question, we're given the model, right? The equation that relates time and value. So it's an exponential equation. And since it's depreciating, we expect it to look like this, a negative exponential or an exponential decay, right? Rather than gain value, like maybe in the housing market, for example, this depreciates, it loses value. And so we'd expect this value for r to be less than 1. And that just means every year it's losing some amount. But this value here, a, what does a represent? So in an exponential model like this, a represents the initial amount or the initial condition. In our case, it's 4,699. But if you're wondering, okay, well, how do I know that a is actually that? We could substitute in a point. So remember, when time is 0, y was 4,699. So let's substitute. Substitute this point into y equals a times r to the power of t. Right, so y is 4,699. A is what we're looking for. R is an unknown. And t is 0. And so r to the power of 0 is 1. So we're left with 4,699 equals a. So therefore, we found some information about our model, so let's put it back in. So y equals 4,699 times r to the power of t. Now let's just jump back to the question again. So we're looking for the value after 6 years. So we're looking for value. So that's y after 6 years. That's time. So we substitute in 6 years to get the value. But before that, we need a, which we got, but we also need r, the rate of depreciation. So let's work that out next. So this was finding a. Now let's find r. And remember, back up here, we also have this other point, right? This other time value pair. So that's 1500 at 4.25 years. So time 4.25, y 1500. So now instead of substituting it into the model the question gave us, we found a, so let's use that. This model right here. So y is 1500. 4,699 is the same, times r, which is what we're looking for, to the power of t, which is 4.25. Now we have one equation, one unknown, so we can solve for r. Let's divide both sides by 4,699. Equals r to the power of 4.25. And we can take the 4.25th root on both sides. So root 4.25. Sounds a little bit odd, but our calculator can do it for us. And that will just give us r. So on our calculator, we can do, when we want to do a root that's not like the square root, we need to use shift hat. See, it's above ln, or to the left of exit. And on the left, so first we put 4.25, because we want the 4.25th root. Then we do that little x root symbol. Then we put what's under the root symbol. In our case, it is 1500 divided by 4,699. And I'm just using brackets here to make sure it uses that whole expression. And we hit execute. So r equals 0.764. All right, so we found r using the other point. Again, we're building up our model. So now substituting that in, we get 4,699 times r, 0.764 to the power of t. So this is our fully characterized model. What I mean by that is we can put in any input, t, to get any output, y, or we could go the other way, right? Put in an output, y, to get an input, t. So we can finally answer the question, right? What is the value after 6 years? So finding value after 6 years. So that's when time t equals 6. Now I guess before you even got this far, we should kind of have a guess, right? So we can then reason about if we're close or if we're way off. So just looking at this, my little sketch up here, it's got to be less than 1,500, but not too much less. So maybe like $1,000 would be reasonable. So if we got something more than 1,500 or like much less than 500, we might need to revisit our working, right? But let's hope we don't get that far, or be that incorrect rather. All right, so let's substitute it in. So y equals 4,699 times 0.764 raised to the power of 6. On our calculator, 4,699 times bracket 0.764 bracket to the power of 6, execute, 934.47. which is about $1,000. So that looks about right. So after 6 years, the computer will have a value of $934.47. So maybe don't sell it, just hold on to it forever.